b.log, and I happen to know that the b has 4 different elements in it, 4 names, and let me try to access the 5th element by using the index 4, and this will be undefined. So just like a variable without any value assigned to it is undefined, so is a element of an array undefined if we don't give it a value. Now, I can also just programmatically determine the number of elements in an array by using a special property called length. So I can do console.log a dot, and remember the dot is the member access operator. So arrays are objects, and this particular object has a special property called length, which will give me the number of elements in that array. So I would expect to see, let's see, 1, 2, 3, 4, 5, 6. So the question is it going to give us 6, the actual number, or is it going to give us to it in a zero-based fashion? And the answer to that is that it will give us the actual number, not zero-based. And this will come into play a little bit later when we use the length of an array and we iterate through each element of the array to print them to screen when we learn about looping. All right, so just keep that in the back of your mind. Now, there's a lot of strange things that you can do with arrays, and some of them are not always intuitive. Like, for example, if I wanted to just randomly create a new element, so in this case, I'm going to create use the index 10, which means this would add an 11th element to the array. What happens with all of the elements between where we left off, 0, 1, 2, 3, 4, 5. So 6 through 11, what will we get? So let's just assign this to 77, and then I want to do a console.log of a, and then I want to do a console.log and a.length, like we just learned about, and kind of see what happens here. And then let's run that. All right, so we can see that it prints out 4, 5, 6, 7, or I'm sorry, 4, 8, 15, 16, 23, 42, and then it says there's 4 empty items, and then there's 77, and it says that there's 11 items, 11 elements in this array because we filled up the 10th index, or index 10, with a value. So it will create essentially what's called a sparse array, and that means that there are empty elements inside. Now, this isn't usually the way that you want to work with arrays if you need to add new values, because it's not as safe. We're inadvertently creating elements with nothing in them. There's a safer way to go about this using some additional built-in functions of the array. And so if I wanted to add that value and add it to the end of the array, no matter how many elements are currently in the array, I could use the push method. And so I say, hey, I want to push the number 77 to the end of the existing array. So let's copy this and paste it here. And then if I wanted to remove it, I can use a method called pop. So this function pop will remove the last element of the array. In fact, I can call it several times to keep removing elements of the array. And here we'll just print out what the end result is, just like we did previously. So now this should put some fireworks into our terminal window. So you can see that using push in line number 29, I was able to add the number 77 to the end of the existing array. And that gives me 7 total elements. Now I call pop 3 times. It removes 77, 42, and 23, leaving us with just 4 elements in our array. Okay, so we're going to continue to use arrays. They're a great way to keep lists of things together and accessible, and they'll become even more important again as we learn how to loop through arrays and to evaluate each element. We can even use arrays to hold on to other things like objects and functions, and we'll learn about some advanced use cases with arrays a little bit later. All right, so that's all I have to say about arrays. Let's move on and start looking into some things that are beyond the absolute basics. We'll start moving and talking about functions. All right, see you there. Thanks. Throughout this course, even from the very first line of code that we wrote, we used the console.log function to print things to our terminal window. And I kept referring to log as a function as part of the console object. In its simplest form, a function is merely a block of code that we as programmers can name. And once it has a name, then we can call it by its name. But it's just one or more lines of code that we put into a block, and then we say we want to execute that block over and over and over again throughout our application. So again, that's a very basic explanation of what a function is, but in JavaScript, functions can do so much more. In fact, most of this course will be devoted to working with functions because, frankly, they're one of the primary constructs in JavaScript for getting things done. So first of all, let's go ahead and create a new file. I'm going to call this function declarations.js. All right. And first of all, if I have some code that I want to reuse throughout my application, I want to add it to a function. So we can create a function, and I'll walk through and explain the parts of a function here in just a moment. Let's create the most basic function that I can possibly think of. And I'm actually going to copy and paste some code in so we don't have to type it all. But nothing here should be all that revolutionary. So I've created a new function called say hello. Notice my name. I use camel casing, right, in order to name my identifier, my function name. All right. And then I have 3 lines of code. Notice that they're inside of these curly braces. Notice that they're indented, so we see kind of a relationship between this code on the inside and this line of code and this line of code on the outside. So it kind of represents a container relationship. This code sits inside of, or is part of, or is rather the body of the function that we've just declared. All right, so here we just declared a simple function. This is called a function declaration, this style. We're going to look at other ways to define functions later, and I'll draw your attention and why you'd want to choose one or the other later. There's at least 2 other ways that I'm thinking of off the top of my head. But first of all, notice that we use a keyword called function. Then we give the function some identifier that we come up with, something meaningful. We'll use similar rules to what we use for variable names. All right. Then we use an open and close parenthesis. You'll see how these will be used in a little bit to define arguments or input parameters to our function. But right now it's empty. We don't require that the caller give us any additional information. And then we use the open curly brace here and the close curly brace here to define the container, to define the code that we want to be the body of this function. And everything inside of that is just any JavaScript that we want to write for the most part. All right, so how do we actually then use this? Well, we gave this block of code as defined by the open and close curly brace. We gave it a name, and so we should be able to call it by its name. So I should be able to do something like this, right? Say hello. And that will get me most of the way there, but to actually invoke a function, we have to use the function invocation operator. In this case, it's the opening and close parenthesis, and obviously we want to use our end of line statement here. So let's go node and then function declaration, and let's see, declaration, sorry, there we go. All right, and we get hello. So hopefully you weren't expecting something super interesting. We're just printing out 3 lines with what I would call a flower box kind of around it, some dashes to style it up a little bit. We can do some interesting things with regards to assigning the function to a variable. So let's do let a equals say hello. Now, do I want to invoke the function here? No, and I'll explain why in a little bit. I merely want to get a reference to the function, and then I'll do a and invoke the variable. So this variable is now pointing to this function, and now I say, okay, I have a function inside of this variable, go invoke it using the function invocation operators. In fact, here, let's do it a bunch of times just to make sure that we're seeing what we think we should see here. And so we can see hello, hello, hello all 3 times in a row. Great. So let's comment that out. Now, up to now, this function's not all that interesting. Let me just copy it, and I'm going to comment it out, and I'll create a new version of this function down here beginning in line 17. And I want it to actually allow me to pass in a name so I can say, hello, Bob, hello, Steve, right? So we'll just create a new argument into our function say hello by giving it a variable name. So essentially, now we're able to use this variable name in the body, and we expect the caller to give us the name it wants us to say hello to. So here I'm just going to use some string operators here with name and make sure things are spaced nicely. And so here I can do, say hello to Bob, say hello to Beth, say hello to Mr. Tibbles, my cat. All right, and let's go ahead and run it. And you can see now how I'm able to reuse that code, but change it up by passing in the name that I wanted to say hello to. All right. So let's comment all this out, and let's talk about one more thing that we can do with functions, and that is return values from functions. So this first function that we created, it's merely just outputting. We're not expecting it to perform some operation and then give us some value back. But what if I wanted to create a more interesting function that implements some business rule in my system, in my e-commerce system, like to calculate the sales tax on a given amount, say a subtotal of all the items that are in my shopping cart. I might create a simple function called calculate tax, like so, and we'll get to the body in just a moment, but I want to allow the caller to pass in the amount that we're going to charge tax to. All right. Then I'm going to say let result, just the name of a variable result, be the amount, that value passed in, times 0.0825, which is the sales tax where I live. And then I want to use the keyword return and then the value I want to return. So you can return one value from a function. In this case, I want to return the amount of tax. So I'm going to return result. Now what I'll do is I'm going to call calculate tax, passing in an amount. So let's say $100. And I want to capture that into a variable. I know it's going to return a value to me. So let's just do let, and I can reuse the variable word result, but I might use something more descriptive like let tax equal calculate tax, and then console.log the amount of tax, like so. Let's save that, and then let's run it. And you can see that for a $100 purchase, it would charge $8.25 in tax. Okay, but that's what the purpose of the return keyword is, to actually give me back something. So this is an expression, a function invocation expression. It's going to give me a value back that I can then assign to the new variable tax, and then I can work with that value, in this case, in a number representing the amount of tax. All right, and I think that's all that I'm going to say about this for now, but there's lots to say about functions. It's going to, again, consume the majority of this course, and you're going to have to become very familiar with the ins and outs of working with functions, and we'll start that process in the next video. We'll see you there. Thanks. In the previous video, we learned how to create a function declaration. And a function declaration and a variable declaration are similar in so much that they both have an identifier or a name because we plan to call them later on in our JavaScript. But what if we don't need a name? What if we're in a situation where there's just a need for a function, but that function will never get called for the rest of the application, and we know that. Then we can take a different tact. We don't need to add a new identifier. We can just create what's called a function expression, and we don't have to supply a name. We just give it the body of the function and say, here, go do this when you need to run some code. All right, and a good use of that is whenever we need to create some code that should run in the future. So here, let me start off by creating function expressions.js, a new file. And here I want to use the set timeout method that's available inside of JavaScript. And if we use IntelliSense, we can see that there's actually two input parameters to this function set timeout. We're going to first of all need to give it something called a handler, which I happen to know is just a function. Now I could give it a function declaration, but usually people just create function expressions here for the handler. And then the second thing we'll need to do, and I'll use the down arrow to move from the first argument to the second argument, is to give it a timeout. And so that's the number of milliseconds that I want it to wait before executing this code. And I'll show you how that might be interesting in just a few moments here. But the first thing we need to do is create a function expression to pass in. So just here right in line, I'm going to create a function open close parentheses, open close curly braces, which denote the body of this expression I'm creating. Inside of here, I'm going to do something simple like console.log I waited 2 seconds. And then here at the very end of the function declaration, I'm going to give it that second argument, the number of milliseconds that I want to wait before executing that function expression. So I'm going to say wait 2 seconds, and then I want you to call this inline function I'm creating, and the body of it will merely just log out I waited 2 seconds. All right, so here we go. Let's go and do node and then function expressions 1,1000, 2,1000, and you can see it prints to screen I waited 2 seconds. All right. Now it's kind of hard to read it like this all in line. One of the things in JavaScript that's a little bit challenging, especially if you're getting started, is the number of curly braces that you'll encounter. And differentiating, for example, this outer set of parentheses and this inner set of parentheses. And Visual Studio Code tries to help you. Like when I put my caret right next to that opening curly brace, it tries to find the matching closing curly brace. And you'll see as we add more curly braces for different purposes and indentation levels inside of our application, Visual Studio Code does a pretty good job most of the time of finding its match. It's just a matter of looking for that caret that surrounds the closing one. Here over you can see whatever in column number 61 here. I'm looking at the bottom. Okay. Anything inside is just the body of the function, and the same rules apply. Whoops, I didn't use a semicolon at the end of that line, but I should have. All right, it shouldn't change the function in this simple case, but nothing changes about how we work with this. Now, to be honest, most people do not put this much code on a single line. I may want to split this up into multiple lines. So I would do this in a way that feels natural to me. And you can see that as I put my mouse cursor next to where I feel like the split should have been, like at the beginning of console.log, and here at the end of our body of our function expression, Visual Studio Code naturally will create some indentation. Now, if I don't like that level of indentation, I'm free to come in here and to change it up. Like I would prefer to use a tab here. So I'm using the tab key on my keyboard to move things out and the shift tab to move things back. That only works if my mouse cursor is here right at the beginning of that line. If I were to move one character in and use the tab key, well, that's not what I want at all. That's going to split that word up. But if I use the keyboard, the arrows on the keyboard to maneuver, and then the Shift tab to move it out. I can move things in and out. But that is pretty much how I would like to see that function represented, right? And then I use a comma to pass in a second argument, in this case, the number of milliseconds to my set timeout function. All right. So, but the focus of this is that function expression. I never want to use that function again, but I need it in this case as an argument to pass into my set timeout function. All right. So functions can take functions as input parameters. Okay. So just keep that in mind because things are going to get a lot crazier than that. And let's move on and talk about using both the function declaration and a function expression to do something just a little bit more interesting here. Same basic idea here, but what I want to do is start off with a counter. And this will count the number of times that we actually execute our function expression. I'm going to start with a function on the outside, function timeout. Let's call this function timeout, like so. And then inside, I'm going to set timeout using that built-in function to JavaScript and pass in a new function expression. All right. And then I'm going to here give set timeout, say in 2 seconds, I want you to basically run this function expression that I've defined right there. So I pass in the second argument of 2000. Again, using Visual Studio Code to help me find the matching set of parentheses at the beginning and the end to pass in the input parameter to the set timeout function. Recognizing that the function expression is the first argument to that, and 2000 is the second input parameter to that set timeout function. Here's what I'm going to do now. I'm going to append, so I'm going to put a little space there between hi and the closing single quote mark, counter. But I want to, after every time I reference counter, I want to increment it by 1. So this will allow me to count the number of times that set timeout has run. Now, one of the things that I want to do is after I have printed that line, I'm going to schedule the next time that this code should run. So I'm going to schedule and call timeout in a recursive manner. So I'm using the name of this outermost function and saying, hey, now that you've run me again in 2 seconds, because I'm going to basically call set timeout again. All right. Now I need to kick this off the first time, so we'll call set timeout once here on line number 15. And that will kick things off, and then I'm going to hit Control and C on my keyboard to stop the execution because it'll just keep looping and looping and looping. All right, hopefully in your mind you understand the sequence of events here. I'm going to call this function declaration once. The body of that function will create a set timeout. In 2 seconds, I want to execute this function expression, which will not only show me the number of times that this function has been called, because I'm keeping count of it in that counter variable, but then also it's going to call the timeout function again, which will schedule 2 seconds from now the next call to the set timeout function. Okay, so let's see it run. Hopefully this all makes sense. So I waited 2 seconds, saw it run once. All right, so twice, 3 times. And you see it'll just keep going every 2 seconds until I hit Control C on my keyboard to stop its execution. All right. All right, the last thing that I want to show you now, I'm going to comment all this out, is that you can create a function declaration, or I'm sorry, a function expression that says something like console.log, And I'll make something a little bit more interesting later. And then I can immediately invoke that function by, first of all, surrounding this function expression in parentheses, just to kind of say, hey, I want to group all this together, and then using another set of parentheses as the function invocation operator, like that. Do you see that format? So there's this inner set that we use just to define input parameters. We don't need any, but we still need it in order to create a function expression. Then we're going to group this whole thing together and say I want to execute it. So there's actually, what, 4 sets of parentheses. We just have to keep them straight in our mind of what each of them are doing. But this last set will do what's called, and this kind of structure is called an immediately invoked function expression. In other words, I will have a function expression and I want it to be invoked, immediately when this application is run. And this actually is a pretty common pattern in JavaScript development. It comes in super handy, and we'll talk about why it comes in handy a little bit later. But we want to just remember immediately invoked function expression. It's also just known as an IIFE. Sometimes I think it's pronounced iffy. All right. So keep in mind iffies, and we'll come back to them a little bit later. All right. So let's move on and move away from functions just for a little bit. We'll come back to them later. But hopefully you can now tell the difference between a function declaration and a function expression. Most importantly, for our purposes, you want to keep in mind what immediately invoked function expressions are. Okay. All right. So we'll come back to this and let's move on. See you in the next video. Thanks. In this video, we're going to talk about decision statements. There's actually 3 that we're going to consider. The if, the switch, and a ternary operator. And so whenever we need to add logic to our application, in other words, perform different blocks of code based on some condition that we evaluate, we'll want to use one of these decision statements. And so let's go ahead and start by creating a new file called decisions.js. And here what we'll do is start with the if statement. So the basic structure looks like this. If, and then we'll evaluate something here, some expression. So let me just kind of start off with this. Some expression, that expression should equal true or false, and there's lots of ways to evaluate this. We'll come back to it in just a moment. But we'll consider those in between the opening and closing parentheses. If that is true, whatever that expression is, then we'll execute all the code inside. So let's begin simple. Var count equals 3. We'll just hard code a value and then say, so if count, and then we'll use the equality operator. So this is going to evaluate for equality. If count indeed is equal to 4, then we will that expression will return true. If it's true, then we'll perform whatever code we write here. So console.log and count is 4. So the first time we run this, we're not going to get really anything. All right, so the first time we run this, we're going to not get anything. It'll just exit. What we can do is change this to count equals 3, like so. And now when we run it, we'll see the message count is 3. All right, very uninspiring. Let's set this back to 4. And here we can consider the alternative that the count is not equal to 4. And we could kind of give the counter message, count is not 4. This much we know to be true. All right. All right, so count is not 4. We basically skipped over this block of code because this returned false. Therefore, we executed the else statement, this second block of code, and skipped over the first one. Okay. So there's actually several different variations of this we can use because there are some different conditions here. Maybe I don't want to jump right to that else statement. Maybe I want to keep evaluating. I can use an else if. And so here I might say else if the count is greater than 4, then I could maybe do a message like console